Well, first of all, congrats. This conference is one of the 5 top central bank conferences in the world. And I'm very glad that it's still there because I started this conference 26 years ago and did it for 10, 11 years. So it's very good to be here as a discussant of a wonderful paper, actually. Let me go immediately into business, asking somebody, oh yes, this here, to go forward. So what does Marshall do and his co-authors? I went through his 2015 paper, his 2023 paper, and this presentation, which is not so clear. I understood many things now better because you put some words where there were graphs or numbers, so I appreciate that very much. He develops a very original model to understand better and quantify the GDP effects of climate change. Now, this is absolutely key for assessing losses and damages and possible transfers to countries, to regions which are most affected by climate change. Although I have more than a grain of salt about this, their feasibility. Now, what's the main contribution? What he and his authors do, he addresses inconsistencies between micro and macro results. It's basically a macro study, panel, GDP, time series, econometrics, for a large panel, really large panel, a fantastic panel of 60 years in 190 countries, taking account precipitation and temperature effects on growth, and its implication for GDP levels. Main results, economic productivity is non-linear in temperature, really GDP more than economic productivity, peaking at 13 degrees centigrade, declining strongly at higher temperatures. It's non-linear, sort of quadratic. It's not exactly quadratic, but quadratic function. Climate change will reduce average global income by roughly 23% by 2100, was in his 2015 paper. Now, in your presentation here, it's around 10%, which still is large, much larger than, I think this is for 3 degrees, plus 3 degrees, plus 3 degrees, 10%. And then very interesting calculation about the effects of 1 ton of CO2 emitted in 1990 causes $4 in global cumulative discounted damages by 2020, 3 years ago, and an additional $327 in discounted damages through 2100 at 2% discount rate. So great paper. I don't have too many specific recommendations, and I will do, to a large extent, general comments on how this line of research could be extended in the future. Now, on this, let me start with GEC. What is GEC? I invented this acronym. It's a global environmental catastrophe which we are facing. And the scenarios of climate change, according to IPCC, they reflect a very large dispersion, but scientifically based, with probabilities sometimes assigned to the different scenarios. A time trend and upward revision of probabilities associated to more catastrophic scenarios. What does it mean? It means that every 2 or 3 years, the projections are more pessimistic by IPCC. And certainly a strong presence of nonlinearities and catastrophic trigger points. More worrisome is that there are very few scientific models, to the best of my knowledge. I'm pretty ignorant, so this is a very, how should I say, patudo in English, a very patudo kind of assertion, but no estimates of the economic effects of the interactions between the 5 direct drivers, according to IPBS, of the anthropogenic GEC. For example, I have not seen scientific models of the interaction, although Tamar mentioned a little bit this at a qualitative basis. No scientific models of the interaction between global warming, wildfires, desertification, more land use, and more global warming. So these type of interactions, this is just one example, are typically not much modeled. And certainly no estimates of the economic effects and socio-economic feedback to the environment. that's a problem because our world is one of 5 drivers and not just one driver. Now, on the GDP effects beyond this paper, they're highly sensitive to model specifications. The dependent variable presents some micro foundations that relate temperature to output levels. This is in Dell and others. Sector-consistent macro models for GDP growth, which has been done by Burke, by Marshall and his co-authors. And growth effects compound over time. Predictions of future losses vary enormously. Level effects do not, which is a point which is at the heart of what you do. The temperature functional form, the linear effect, could be linear, like in Dell, or higher order polynomials, like in your work, and I think there is a great value added in doing it with a higher order polynomials. And this affects enormously the magnitude of damage estimates. Let me go to simply a listing of the literature, which identifies different mechanisms of transmission from temperature increases to GDP. And there are those models which identify levels and other growth effects, and very different dimensions regarding other parameters or specifications regarding temperature functional forms, country fixed effects, year fixed effects, region and year fixed effects, time trend polynomials, and so on and so forth. And this implies an enormous variety. I went through Newell et al.'s paper of 2021, which was also quoted by you in one of your papers. Look at the enormous difference across different columns, and within a column, across different specifications, year fixed effects, region, year fixed effects, with time trends, with no time trends, and so on and so forth. Let me focus on the one number which sits there in the middle of the upper part, which is 49.4% loss in GDP as a representative average number across different studies. This is done by the simulations by Newell et al. 2021, which follows a methodology in this little cell, minus 49.4%, the effect of global warming on GDP by 2100, as compared to the 23% presented by Burke and co-authors in their 2015 paper, or the 10% which you present in your figure. So this comes close to his methodology and his co-authors. But look at the variance. Look at the variance. Some effects, some studies, some simulations have positive effects because they are on regions which benefit from climate change, and the upper dimensions far away from the latitude of the equator. And others, however, have very, very negative effects of minus 56%. Now, this is for the A category of models, which are GDP growth models. If you go to GDP level models, look at that dispersion. It's around minus 2%, minus 1%, minus 3%. It doesn't move away from single-digit numbers. So this is an example how the different specification and model can yield completely different results, and that's certainly a problem. Here's a dispersion of studies, which basically presented by Newell et al. It's simply amazing. Now, GDP is not welfare, is a point which you raised in your presentation too. There is, and here I want to make 3 points. One is that the mechanisms through which climate may affect GDP are many, are complex and hard to analyze comprehensively, an old point made by Dell. Even if we were to know each mechanism, we don't know how these mechanisms interact. Now, economic aggregates are not direct welfare measures and do not reflect non-market values affected by climate change, the quality of life, health not measured by health expenses, and so on and so forth. The complexity of the climate-economic relationship is apparent in different sector studies: agriculture, ocean fisheries, freshwater access, storm frequency, migration, tourism, mortality, and even conflict. Now, loss and damage compensation. Is it feasible? And before that, which are the questions which we have to address? And some of them were also mentioned by Marshall. The estimates of social cost of carbon, SEC, are highly sensitive to the discount rate. For instance, 4 to 8 times of differences in SEC when we compare a 3% rate with the Ramsey discount rate. Let's remember the Ramsey-Koopmans discount rate. RT is delta, which is the pure annual rate of discount, plus the aversion to risk, rho, times the growth rate of the economy. Now, once we take into account that G, the rate of growth, is also endogenous to climate, then R will be endogenous to climate and may change over time. We know since Usawa 1961 that rho, the risk aversion, depends on the level of wealth. The wealthier you get, you're less risk averse because you move away from subsistence levels of consumption or income. So this is a very complex, it seems to be very simple, it's a very complex formula, equation. It interacts with many other parts of overall model of the economy. And it's very hard to choose a socially optimal discount rate and its change over time in order to calculate the present value for the SEC. If I were to ask you personally, what's your personal discount rate? It's plus 5%? Is it 0 or is it minus 5? That would take too much time to you to respond, but let me venture my own personal subjective discount rate, minus 5%. When should we start to calculate loss and damage? It's not clear when to begin counting emissions that parties should be held accountable for in order to come for a sensible compensation scheme. Consumption or production-based emissions, should we be held responsible for emissions associated to production or consumption? There's a huge difference because many developing countries are producers of some stuff like oil, and importers of other stuff which they consume. So I'm very skeptical regarding the loss and damage, not the calculation actually, even though the range is huge, is immense, but about the political feasibility to do this in any near future, which does not excuse the world at an aggregate level not to finance, let's say, maintaining the Amazon basin and preventing that it is burned down over the next 10 years. Implications. Where do we have firm science? Basically only up to now accounting for CO2 flows. And this is the figure taken from this week's fantastic special issue in The Economist, which presents simply the graphs of inflows and outflows of CO2. The stock we pretty surely know that there's 1 trillion tons of CO2 which have been accumulated up to now thanks to humans, obviously. Flows per year now, human caused gross flows into the atmosphere, 41 billion tons per year. Total Earth's net flows into atmosphere, 19 billion tons. Is it small? No, it's terribly large. It's small compared to what naturally is exchanged between oceans, waters, the earth, and the atmosphere out and back. It seems low, but obviously it's all our contribution is what caused all of climate change over the last 100 years and the next 100. My second point, and almost I am at the end, is that science is shaky regarding forecasts, and the commitments are even shakier. The IPCC AR6 scenario, which is graphed there, assumes commitments to achieve net zero by 2050 or 70, as long as they are enforced. And we see very little enforcement up to now. It's highly unlikely given current trends. Every year the peak of CO2 emissions is pushed a few years forward, or at least 1 year forward. And this is happening since the Paris Agreement of 2015. Carbon dioxide removal, CDR, is still an infant technology and an embryon industry. In Iceland, there are some very low-scale plants, and in other countries too, but it's real an embryo industry. It requires a lot of government subsidy before sufficient scale and more innovation is developed. So the main problem is politics, obviously. It's politics, stupid. Market-based solutions. Among market-based solutions, I think what holds most promise is carbon pricing, enforced carbon pricing, and realistic setting of that pricing. This graph is great because it shows the enormous dispersion of current prices per ton of CO2 equivalent. In the EU trading system, it goes up to $90 or so as of now. In Japan, which is the lowest part of the red on the right-hand side, it's a few cents, US dollar cents is the pricing. In Chile, please correct me, colleagues, it's around $5. $5. In Uruguay, I heard the Minister of Finance at COP26 some years ago to commit to have a price of $100. So $100 in place by 2025, which is the highest commitment, but let's see if they will be implemented by 2025. Well, a fantastic example is different US administrations. Trump forced EPA to reduce its social cost of carbon to $5, which is current Chile's price. Today it stands at 51 under the Biden administration, still very much short of EPA's socially optimal level of 190, which they have published. So, in conclusion, I think this is a wonderful paper. It's a wonderful line of research. It's a promising line of research, which you developed with an impressive research agenda based on estimating micro-macro relationships between global warming and GDP losses. You show large aggregate effects, not an order, but many times the effects shown by conventional IAM studies before, and this is per se very valuable. Yet both science and economics are still far away from modeling, estimating the true dimension of the global environmental catastrophe. The strong interactions between the 5 direct drivers of GEC and their implications for economic aggregate variables and their distribution over time, across countries, across income groups, and their implications for other social variables. We will have massive, massive effects on poverty, migration, crime, wars, health, institutions, and democracy. Effects attributable, which will be traced down to climate change. Every imaginable social, political, and economic variable will be deeply disturbed by GEC. So, good domestic and international policy is the only way to avoid the most severe consequences of GEC, which means that we have lots of work to do. Many thanks.
Thank you very much, Klaus. So now we have a few minutes for a couple of questions from the Eduardo.
Yes. Thank you very much. Excellent presentation, Marshall and Klaus, the discussion. I may have understood this wrongly, so I apologize if I did, but it seems to me that based on the differences of the results that you showed from your 2015 paper to this paper, the aggregate effect from minus 23 in the 2015 paper to minus 10 now seems too large. But I may have gotten that wrong, so I wanted to ask if it's indeed very large and what's your explanation, because the results don't look that different to your 2015 paper, no?
Yeah, apologies for not making that more clear. The largest difference is we are evaluating at a different temperature in 2100. So our previous paper assumed we're going to get about 4.5 degrees warming by 2100. That's what we thought, circa 2015. Now those estimates have come down a lot. They're closer to 3C. And so really it's just the cumulated effect of that 1.5 degree difference, which again, if you're pumping that through growth rates, is a really big difference. So nothing fundamental has changed on the response function. It looks pretty similar. It's more tightly estimated. The only difference is the temperature we're evaluating at.
Thanks. James and Elias?
Yeah, a really nice feature. This is great. A really nice feature of the simple SCC calculations that you're doing is that they really don't involve too many moving parts, which means you ought to be able to put things together in a way to get some confidence intervals that are interpretable. That would be nice to see. And then a question on the local projection results. Great that you're doing that because it's a nice complementary tool. It looked like those were essentially, especially for the already hotter countries, essentially a levels effect. Now, it only is going out 10 years, but there's like this decrement. The dependent variable is log of future minus log of past, and so it's going to just have a straight percentage on GDP interpretation, and those lower lines were pretty flat. So I wonder if you've thought about it only goes out for like 10 years as opposed to a longer thing, but it looked to me like that was giving qualitatively somewhat different results.
Yeah, that's a good. I think maybe we should try to run it out further and try to distinguish you run out of sample pretty quickly because you have to run the lags out. So I don't know the best way to deal with that. One thing we thought about to gain power is to go subnationally. So there are estimates of subnational GDP, which gives you sort of a wider, maybe you can claw back some power. But you're right. I think the short answer is we need to run out further.
Elias?
So thanks for a great presentation and great discussion, as usual, Klaus. I also agree that the 10% is larger, but still way small, I think. So let me give you one additional thing that could be added perhaps in the econometrics here, which as far as I understood is not included, and goes back to a comment that came out in the panel yesterday. You also we will have more frequent extreme events. So some might be captured when they're extreme temperature events or rainfall events, but a cyclone is not captured here. And the number that came out yesterday is that, I don't know, they're 5-7 times more likely. So even if they don't leave a persistent effect per se, it's just they're 7 times more likely. So they add up. And they do probably leave a persistent effect, right? That was the comment made yesterday, right? Because they increase debt, and debt we know from just traditional macroeconomics that particularly in poor countries, that drags on growth with a significant effect. So maybe, at this point, maybe in the US or other advanced economies, you get a cyclone and the effects are kind of small in GDP, but for other countries, the effects are big. And I would venture to say they're also persistent. And this stuff, you just add it up, because it has nothing to do with the regressions that you're running. So this is totally additive. So I think that's one way of getting that estimate larger. I don't know if much larger, but probably much larger for some countries. Thanks.
Are you a referee on this current paper, Elias? This is the exact comment we just got. Well, why don't you also do, and I think you're totally right. And so, as you mentioned, and as Eduardo mentioned, there is great work showing the persistent impacts of tropical cyclones, of extreme heat waves, so even separate from the sort of mean annual temperature. So even within temperature, if you look at the extreme part of the distribution, you get some additional effects that we don't pick up. They're smaller than the changes in mean. So even with temperature, you get more. Certainly with precip, there's papers showing that precip can have an independent effect that's not fully correlated with temperature. And cyclones, I think you're right, is the biggest one that's not in here that I think you're right is almost fully additive. It maybe has a little bit of correlation with temperature, so maybe we're implicitly picking up a bit of the cyclones, but I think you're mostly right, and I agree with you entirely. Just more work.
Okay, so I think, we have time for 1 or 2 more questions. Yeah, Tony.
Thanks. That was a great paper. I learned a lot. I just wanted to follow up on what we were discussing yesterday, just to give you some more chance to help me out here. I still worry in this literature, and it's not just in this paper, but in this whole literature, that we're using temperature shocks, a short-run response to estimate what happens if there's a permanent change in temperature. So we're really interested in climate. Well, maybe we're interested in temperature shocks per se, but we're interested more in climate. So I still worry, is this really picking up the long-run response, to a permanent change in temperature. Maybe you could just help me out a little more there and what your thinking is along those lines.
I think that's right. So I sort of stated this problem and then ignored it. So thank you for bringing it back up. So I think there could be some additional statistical approaches that could help shed light on this, even in the historical data. So one that we've tried before is looking at long differences. So you use longer-term, slower-moving variation in the historical data and ask whether that has, what effect it has, basically. Does it have the same effect as the sort of short-term shocks that you see? Does it have a different effect? And that's a way to try to understand empirically whether responses to slower-moving changes in temperature or some climate variable look different than the faster moving stuff. We need to run that in the GDP data. We have not run that yet. We've looked at this in U.S. agriculture, and there you see basically identical responses to longer run variation as you do short run variation, which to us is evidence that either there's no adaptation or we're somehow picking it up in the short run stuff. We haven't run it with the GDP data. You're sort of short on units with the GDP data, so it's a power problem. The earlier DJO paper did a version of it. It was noisy but looked consistent with their panel estimates. We should just try again on our data. That's a great point.
Klaus. Yeah, sure.
Very briefly, I'm not quite sure. There's a comment on the comment. Elias, you raise a point that maybe you could in your paper consider some consequences of climate change which are not exactly the increase in temperature, like hurricanes. Is it just an example? Because there are many, many more examples, like, for instance, precipitation in a country like of Chile doesn't come now. It comes down in liquid form and not in snow, which means that during the rainfall season, California, maybe the same happens. It comes down as water, and that water, the huge deluge of water, causes tremendous damage, which is another example. The other is obviously wildfires, California, Chile, Australia, Mediterranean area, the world over. So you have lots of consequences which are directly attributed to the rise in temperature, not just hurricanes, and this should be considered too.
I agree.
Hyun, last question. You have to push the...
Okay, perfect. Yeah, just building upon the discussion, I was wondering if you have thought about compound risk. So this temperature can obviously co-vary with these other types of disaster, but what would be interesting would be estimating the compound impact. So one natural disaster happening, two disasters happening at the same time may not be, it could be greater, the damage could be greater than the sum of the two. So it'd be really cool if you can estimate that effect.
I agree entirely. I think that's going to be easier done in the sort of microdata that Tama showed than our much smaller number of observations in the macro data. We've been arguing about growth and level effects just because we're underpowered to distinguish them in the macro data for a decade. I completely agree with you as an important thing to look at. I do worry about power in the GDP data.